So, a data warehouse. A data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of organization's decision-making process. Now, architecture of a traditional data warehouse. There are multiple data sources like operational databases or external sources. Then there is a bottom tier where the data warehouse is there, which is a collection of data marts. And then there is a middle tier that has OLAP server. And then there is a top tier where query reports, analytics, data mining, etc. they happen. Now the disadvantages of traditional data warehouse are, for a business service company, it is difficult to set up and deploy and manage, and it is difficult to scale up or down. Then there are multiple performance issues, and then the costs are always spiraling. Now, these problems could have been solved with the help of a cloud solution, and Amazon Redshift is a cloud solution for the same. Redshift is a cloud-based service or a data warehouse service that is used for collecting and storing data. Also, it enables a user to analyze the data using BI tools and simplifies the process of handling large-scale data sets. Advantages of Redshift are: it is a high-performance solution, low cost, scalability, availability, security, flexibility, and simple database migration. Architecture of Redshift is that there is a client application which connects to the data warehouse, that is Redshift, through JDBC or ODBC connection, and the connection is made to the leader node. The leader node then creates the compute code, and that code is sent to compute node, which has node slices. Compute nodes are categorized into slices. Each node slice is allotted with specific memory space where it processes its workload. These node slices work in parallel in order to finish their work. Leader nodes manage communication with client programs and all communication with compute nodes. It parses and develops execution plans to carry out database operations, especially the series of steps necessary to obtain results for complex queries. Based on the execution plan, the leader node compiles code, distributes the compiled code to the compute nodes, and assign a portion of the data to each compute node. The leader node compiles code for individual elements of execution plan and assigns the code to individual compute nodes. The compute nodes execute the compiled code and sends intermediate results back to the leader for final aggregation. Each compute node has its own dedicated CPU, memory, and attached disk storage, which are determined by the node type. Redshift provides two type nodes: dense storage nodes and dense compute nodes. Each node provides two storage choices. A compute node is partitioned into slices. Each slice is allocated a portion of the node's memory and disk space, where it processes a portion of the workload assigned to the node. Massively parallel processing. MPP enables fast execution of the most complex queries operating on large amounts of data. Multiple compute nodes handle all query processing leading up to result aggregation, with each core of each node executing the same compiled query segments on portion of the entire data. Columnar data storage. Columnar data storage for database tables is an important factor in optimizing analytical query performance because it drastically reduces the overall disk input-output requirements and reduces the amount of data you need to load from disks. Data compression. Data compression reduces storage requirements, thereby reducing disk input-output, which improves query performance. When you execute a query, the compressed data is read into memory, then uncompressed during query execution. Loading less data into memory enables Redshift to allocate more memory to analyzing the data. Then there is Query Optimizer. The Redshift query execution engine incorporates a query optimizer that is MPP aware and takes advantage of the columnar oriented data storage. Result caching. To reduce query execution time and improve system performance, Redshift caches the results of certain types of queries in memory on the leader node. When someone submits a query, Redshift checks the result cache for a valid cached copy of the query results. If a match is found in the result cache, Redshift uses the cached result and doesn't execute the query. Compiled code: the leader node distributes fully optimized compiled code across all of the nodes of a cluster. Compiling the query eliminates the overhead associated with an interpreter and therefore increases the execution speed, especially for complex queries. Redshift workload management: flexibly manage priorities within workloads so that short, fast-running queries won't get stuck in queues behind long-running queries. Redshift workload management creates query queues at runtime according to service classes which define the configuration parameters for various types of queues, including internal system queues and user accessible queues.